All right, so today we're going to look at how to find the determinant of a matrix. And a determinant is something that is used to determine whether a matrix has an inverse. And it can help find the inverse. We're not going to get into that in this lesson. Perhaps we'll get into that as well, but for now we're just going to figure out how do we find the determinant. For a 2 by 2 matrix, a determinant is fairly easy. So if I have a 2 by 2, and I have this matrix A, which has the elements A, B, C, and D, we're going to do this sort of motion over here, where we go like this, and then like that. Okay, and so the determinant of a 2 by 2 matrix, which can have the notation of the determinant of A, also this sort of absolute value of A, because what we're going to get out of this matrix is one number. And so you can be the absolute value of A or the absolute value of the matrix represented with all of its terms. And then it's AD minus BC. So again, as you follow this path, you multiply A and D and then subtract B times C. And we go in that motion. So let's look at an example really quickly. So here's my matrix. It's 6, -3, 2, 3. And we want to find the determinant. So again, we do our motion. We're going to do 6 times 3 and then subtract -3 times 2. I'll just use my dots. I'm not a really big fan of times. Okay, whoops, that's weird. Let's go back. So 6 times 3 minus 3, -3 times 2. So this is 18. This is going to be plus a positive 6, and we get a determinant of 24. Fairly simple. When we get bigger, the other thing is determinants only work on what are called square matrices, basically where your number of rows and columns are the same. So a 2 by 2, a 3 by 3, a 4 by 4, a 5 by 5. And in general, and I know this is sort of a lot of writing or a lot of words, but I think it'll be easier once I actually do it with numbers. But to find the determinant of any n by n matrix, so it's a square matrix, you multiply each element in either a row or a column. We usually use the first row. So that's often the easiest, but you can use any row you want or any column you want. You're gonna multiply each element by its minor, which we'll talk about in a second. Then you put a negative in front of each term if the sum of its row and column numbers is odd, and if not, you put a plus there, and then you add up your terms. And your minor for any element, it's the determinant you get for the matrix that is made by deleting basically the row and the column that contain your element. So there's a lot of stuff in here. Let's look at one, and I think hopefully it will get a little more clear. Now for the 3 by 3, so we're going to have 3 terms. So we're going to have one term, and then it's going to be minus the second term and plus the third term. Because if you think of this right here is the first term, or first row, first column, and 1 plus 1 is 2, so we're going to put a plus there. This is row 1, column 2, and that's an even, so we're going to get a negative there. And here we have row 1, column 3, and if you add, 1 plus 1, sorry, that's 2. This is the even, that's a plus. 1 plus 2 is 3. When you have an odd, you get a negative, and when you add 1 plus 3, you get a 4. That's even, you get a positive. So if you memorize the pattern, that's fine. Otherwise, if you add, that's what I was forgetting to do, the row number and column number for your spot. And then an even gets a negative and plus in front, and an odd gets a negative. It's very much like your powers. If you raise a positive or a negative to an even power, you get a positive, and if you raise a negative to an odd power, you get a negative. So hopefully I've not confused you too much, but let's go on and we'll give it a try. So find the determinant of A. So the first thing we're going to do is, and we're going to look at the first row, and then we're going to do another one. So if I'm doing row A, okay, my idea is I'm going to take that 2 times its sort of minor, okay, and then I'm going to do minus 3 times its minor, and I'm going to do plus, in this case, negative 1 times its minor. And what's left is to find the minors. Now to find the minor for 2, for this right here, we are going to knock out its row and column. And what that leaves is this little mini matrix of 2, 4, 5, 6. Okay. Now I can do something similar when I'm trying to do the 3. I'm going to knock out its row and its column. And so the little mini matrix for that is 0, 2, 0, 4. I was getting ahead of myself. Negative 2 and 6. And then finally, for the last element in the first row, when I'm over here, I'm knocking out its row and its column, and I'm left with the little matrix of 0, 2, negative 2, 5. And it can be helpful to write it out. You can also maybe do it sort of in your head. And now I'm finding the determinant of each little mini matrix. And again, as we're doing our determinants, I do this that way, and I do this right here, and I'm going to do that right there. So I have my 2, and I do 2 times 6, which is 12, minus 4 times 5, which is 20. And I'm a big fan of going step by step. If I try and do too much at once, I invariably make a mistake. Even when I don't do too much at once, I sometimes make a mistake. So I like to be careful, and I like to be able to see where I made my mistake if I did. So 0 times 6 is 0, and then we're going to subtract 4 times negative 2. So we're subtracting negative 8, which is like adding 8. And then we have our plus and negative 1 is minus 1. And again, I'm going to take 0 minus negative 4. So that's the same as 0 plus 4. Now I'm going to simplify this all up. And 2 times negative 8, that's negative 16. And I have 3 times 8, that's minus 24. And I have minus 1 times 4, and that's also minus 4. And all those put together, this gives me negative 20 and another negative 24. And my determinant is negative 44. Now, in my instructions, I said you can use any row or column. We usually do the first row, but that's not necessary. So we're going to actually show the same process here, but instead of using the first row, I'm going to use the second row. And the reason why is because of this 0. If you can find a row or column that has a lot of zeros, it's going to make it much easier to find the determinant, because remember, what I do is I take each element and I multiply by its minor, which involves the determinant. Now, and here's the deal, but remember this row we are doing negative plus negative. So I'm going to do a negative here, a plus here, and a negative here. Unlike at the top where we had plus, minus, plus, and at the bottom it's negative, plus. No, it's plus, negative, plus. It's just like the top again. So why I like doing this with the second row is because I don't even have to figure out what this determinant right here is. I know when I multiply by 0, that's going to give me a big fat 0. So I've sort of eliminated some of the work I have to do. And you might say, well, now you're doing all the work anyway. You're doing it twice, but that's all right. So if I want to do number 2, I'm going to knock out that and knock out this. And I'm going to get rid of all these confusing pluses and minuses. And so the determinant, for this number right there, when I knock out its row and column, I get 2, negative 1, negative 2, and 6. And then I can move this over for the 4. So this is out and that's out. And I get 2, 3, negative 2, and 5. And again, I'm going to do my determinant down and back, like that, down and back. So we are going to multiply and find our determinant. So we have 2 times 12 minus 2, because negative 2 times negative 1 is positive 2. And then we're going to subtract 4 times 10 minus negative 6. And if we extend our page, so this is 2 times 10, otherwise known as 20. And we're doing 4 times 16, which is 4 cubed, which is 64. And voila, we get the same answer, negative 44. No matter which row or column you use, you should get the same determinant. And so what this was illustrating is that when you're trying to do your determinant, it's actually nice to find a row or column that has a bunch of zeros because it's going to simplify things. So hopefully now you have what you need for finding determinants. And maybe we'll do a video on how they can be used.